Riemann sums in the definite integral. Definite integral, once again, is just the area underneath your curve. Riemann sums is a process of finding that area. We've been using left endpoint, right endpoint. We have talked about midpoint rectangles. You can actually just choose any point along there. It does not have to be at the end or the middle. Because when you take your limit as the number of rectangles goes to infinity, it gives you the area. So the process of finding the area underneath your curve, once again, is Riemann sums. When we're talking about area above the curve, your height is positive, your width is positive. Multiply two positives together for your rectangle, you get a positive answer. However, the area below your curve is negative because your height is negative, but you're still going to the right, so your width is positive, and a positive times a negative is a negative. Your definite integral is what we have right here. It's a definite integral because it has limits. In the first section of chapter 4, we did not have an upper and lower bound here. So we did not have a definite integral. Those were indefinite integrals, and then you had to remember plus c. But with a definite integral, you're finding the area underneath the curve between these 2 points. B is called the upper limit, A is called the lower limit. So here you're asked to find the area between A and A underneath your curve. Well, A and A, there is nothing between A and A, so therefore your area underneath the curve is 0. Now, over here, we're talking about this, and if we just go ahead and switch our upper and lower bounds, our limits, it really gives us the opposite of the area. We also have the existence of an integral. If your function is continuous, then you're able to take the integral. So let's go ahead then and take a look at evaluating this definite integral using Riemann sums. Well, remember that since we need to use these formulas, b is always your upper bound, so for delta x, we get a b minus 0. Sorry about that. Yes, I messed up. Okay, so we'll get a 4 minus a 0. A is the lower bound over n. So we get a 4 over n for delta x. Your x sub I is really your initial term, your beginning of your interval, which is 0, and putting 0 here and adding something doesn't change it. So it's just I times delta x, which we just figured out here. So we need to come along, take this red stuff here, plug it in here and here. We need to take the blue stuff, which we have right here, and plug it in for your dx. And that's what we're doing. Our red stuff is here, and our blue stuff is out back here. Well, we need to continue to simplify this. Let's go ahead and cube the top, cube this, cube the bottom. So that's a 64I cubed over an I or n cubed. But let's also multiply it by our n to the fourth. Or not n to the fourth, 4 over n. So we're distributing that through at the same time. And so that's how we get this. So then we want to go ahead and take 2 over 1, multiply it by this. Gives us 8I over n. Also multiplied by this here. And so that's how we get our 32I over an n squared. Well, now let's go ahead, distribute through our summation. Remember, you can go ahead and put your constants in front of your sum, and your constants would be these. So we're going to distribute through, pull those constants in front, leaving us only with the I cubed after your sum. The next one, put your constant in front, only leaving you with that I afterwards. Then you have a formula for this, and you have a formula for this. So you're going to still have that in front. Plug in your formula for the orange. Still have this in front of the yellow. Plug in your formula for the yellow. Now, if we were to distribute this through, we would get a 64 when we multiply the first two. Multiplying the next two, we would get some number over an n. Multiply the last one, we would get a number over an n squared. But remember, when you're taking your limit, as n goes to infinity, anything that has an n on the bottom always goes to 0. So when you take your limit of this first part, it's really just that 64. We can do the same type of thing here at the end. When we distribute this through, it gives us a 32 over 2. Distribute that through, really gives us a 16 over an n. But once again, when you have that n in the bottom and take your limit, it goes to 0. So for the last part, it's just a 32 over 2. So we really get a 64 minus a 16, which is just 48. So we're going to do the same thing for this problem. We still need to find b minus a over n. And in this case, it's going to be just b minus a over n. There's no simplifying there since we don't have numbers. We go ahead and we've got to plug in an a for our initial. Then, since we're dealing with the delta x a lot and doesn't simplify much, I'm going to just go ahead and leave it as delta x to begin with. So we got to take that and plug it in. Remember, we're going to write delta x for this. We get that. Distribute your delta x through to each one. Then let's go ahead, distribute through your summation. There's no i's here, so we can pull that stuff out as your constants. Here, we can go ahead and distribute that through. Pull this out in front because your I is afterwards. You have a formula for the sum of 1, which is n, which we have here. You have a formula for the sum of an I, which we have here. Let's plug in what delta x is. And in this case, when you plug in delta x, your n here would drop with that n. Plug in your delta x here. You still have this afterwards. So we have a little bit of simplification there. We're going to go ahead and simplify this part. How do we go from here? Well, this gives you an n squared on the bottom. This n squared times this n squared cancels out, leaving you with a 1, because I'm putting the half in front. This n squared here times this n over 1 gives you an n in the bottom. Well, now we can continue on here. We can go ahead then and take your limit. Remember, your limit has no effect on the stuff that doesn't have n, so this just comes down. We're going to have this right here. This goes to 0 because 1 over n is 0. So now, distribute through. You're going to have to FOIL that out, distribute through your half. Combine your like terms. Your 1/2 b squared. Your ab's drop. And then you get a 1/2 a squared minus an a squared.